Hello. So right now I'm gonna graph this quadratic, which is in factored form. Okay, so this quadratic is in factored form, and we recall that whenever we're gonna graph a quadratic, we're gonna need to know certain facts, or we're gonna want to know certain facts. What are the x-intercepts? What are the y-intercepts? What is the vertex? What is the range? What is the domain? And also whether it opens up or down. Okay. So the first thing we want to notice is that this is in factored form, and so for example, when we're going to try to find the x-intercepts, this is actually going to be very easy if the quadratic is in factored form. So let's do that here. So again, to find the x-intercepts, right? Again, what are the x-intercepts? They're the points on the x-axis where the graph of the quadratic crosses. So in order to do that, we're going to set y equal to 0, and we're going to solve for x. So if I look at the equation of this graph here, and I set the y equal to 0, that's going to give me 0 equals x plus 2 times x minus 3, right? But it's already factored. So what I can do is I can say, okay, this equation is true if x plus 2 is 0 or if x minus 3 is 0. So that is to say if x plus 2 is 0 or if x minus 3 is 0. Okay? If x plus 2 is 0, I subtract 2, and I get x equals negative 2. And if x minus 3 is 0, I add 3, and I add 3, and I get x is equal to positive 3. These then are the x coordinates where the quadratic crosses the x-axis. Okay, so those are our x-intercepts. Okay. Now we're going to calculate the y-intercept. And how do we calculate the y-intercept? Well, we calculate the y-intercepts by setting x equal to 0 and solving for y. Same as before, right? In the previous problems, we were doing the same thing. The only difference was that the form of the quadratic was different. Right here, it's in factored form. So now I'm going to set the x equal to 0 to find the y-intercept. So my y is going to equal 0 plus 2 times 0 minus 3. Right? Why? Because I set x equal to 0. What is 0 plus 2? 0 plus 2 is 2. What is 0 minus 3? That's negative 3. So now I ask myself, what is 2 times negative 3? That's negative 6. So I know that my y-intercept is negative 6. And so now we're going to calculate the vertex. So now we're going to find the vertex of this quadratic. Now here, for a quadratic in vertex form, y equals a x minus h times x minus k. The vertex is x coordinate, which we're going to denote again as the x sub vertex, is given as x sub vertex is equal to the h plus k divided by 2. It's not an accident that I wrote the equation over here as x minus h, x minus k. Well, y equals a times x minus h times x minus k. And that the x vertex here is h plus k. Okay. In other words, like to put it differently, and for reasons that I'll discuss when we're graphing it, it's basically the midpoint of the two zeros. Okay. But if we want to just apply that formula here, I can look at this here. Okay, and I want you to see how I use this, so that if you guys like want to use this separately, you guys can see how to use it, right? So first I'm going to follow here, right? I look at this equation, I look at this equation, I compare it. Aha, my A has to be 1, right? Because there's no explicit number listed here. So the A must be 1. What is the H? Well, if I compare this term with that term, right? If I compare this term and this term, this is x plus 2, this is x minus h. My h here must be negative 2, because that way x minus negative 2 would give me x plus 2. Then here x minus 3, I compare this term to this x minus k. Aha, my k has to be just 3. And I can see that in fact, with these terms, I could get my x vertex as, and by the way, one of the things I want you to notice whenever I'm doing a calculation like this is I'll write my formula down first before I plug in. Because what I always want you guys to do is I want you to do that because it'll help drill it in your brain. And whenever I write down something like this, I want you guys to put it like in a box on your notebook so that you guys internalize these ideas. Moreover, I want you to always notice how I will always state like a condition under which the formula will hold. Because I want you to, whenever I give you like a little piece of information or a fact like this, I want you to understand the full context of that fact's use and applicability. Because as you can see here, in this form, I can't use the vertex formula for the x vertex formula we used before for the standard form, the x equals minus b over 2a. I can't use that directly here. Now, actually, now that I thought about that, of course, I want to show you how I can use that here. But first, I want to take this opportunity to show you this. Okay? So what I'm going to do here is I'm going to plug in now, right? Okay. So h is negative 2 plus my k, which is 3 over 2, which gives me an x vertex of 1/2, because negative 2 plus 3 is 1, and the 2 is on the bottom. So I now know that for the vertex, I have an x coordinate of 1/2. And I'm going to plug in to get my y coordinate, right? So let me do that right away. Okay. Okay. So for example, if I plug in 1/2 here, what happens? Okay, so this will become 1/2 plus 2, 1/2 minus 3. Okay. Now, if you wanted to, you guys could plug this into a calculator. You could also do it the way I'm going to do it, which is going to be a little bit long, but I want to do it this way just so that I can keep you guys on your toes with respect to calculating with the fractions and stuff. Okay. So yeah, actually, before I do this, let me do these two terms separately and put the answer here. So this will equal to something and this will equal to something. Okay, so first of all, what's 1/2 plus 2? Well, I can do 1/2 plus 2 as 1/2 plus 2 over 1, right? Because I can rewrite a whole number, 2 as a fraction, by putting it over 1. But then I'm doing that because I want to put these two fractions with a common denominator, because that's the only way that we'll be able to add them. In this case, I know that I can multiply 1 times 2 to get 2, so that's the denominator I'm going to pick. So it's going to be 2 and 2. I can see that from here, the 1/2 stays the way it is, but this fraction becomes 2 times 2, which is 4. 1 times 2 is 2. And so finally, they have the same denominator, so it'll be 1 plus 4, which becomes 5, and they keep the denominator 2. So I can say that this first term becomes 5/2. And then, but it's going to be multiplied by this, okay? So let's do that one here, okay? So what if I do 1/2 minus 3? Okay, I can rewrite the 3 as 3 over 1, right? So it'll be 1/2 minus 3 over 1. And of course, I'm going to leave a space there for a fraction that I'm going to multiply times this 3 over 1 so that I can get the same denominator with these two fractions to perform the subtraction. Okay. I pick 2 over 2 because if I do 2 times 1, I'll get 2. And so when I multiply these two fractions, I will get a fraction that has the same value as 3, but which has denominator 2. So I'll be able to effectuate the subtraction. Okay. Here I'm going to have 1/2 minus 3 times 2 is 6. 1 times 2 is 2. And so I'm going to have 1 minus 6 is -5. And then, since they're in the same denominator, it'll be 2. So it'll be 5/2 here, and then -5/2 here. Okay? Okay. What else was I going to tell you about this? I felt like, oh yeah, let me just show you something here. Now we know that we were actually subtracting 1/2 minus 3. So here, what is 6 divided by 2? 6 divided by 2 is 3. So in fact, I'm still subtracting 1/2 minus 3. But the key thing with this procedure, which is of course the standard school procedure, is that I'm able to now subtract these because they're two fractions with the same denominator. And of course, that's the whole purpose here, right? And then, so let me get rid of this. Okay. Okay. And now I can effectuate this multiplication. Because how do I multiply these two fractions? Well, I multiply across, right? Now here I have a positive fraction times a negative fraction. So when I have a positive times a negative, it becomes a negative. And so this is going to become negative. 5 times 5 is 25. 2 times 2 is 4, right? And so here we have just gotten the y-coordinate of the vertex, which will be -25 over 4. And of course, we can find out what this will be more or less, well, not more or less, but we can find out what this will be in terms of like a whole number. So we can plot it on the graph by dividing the long division. We know that 4 goes into 25 6 times. Why 6 times? Because 6 times 4 is 24. I subtract and I get remainder 1. So I can rewrite. So if I wanted to, I could also have written this as, and I'm going to put a little arrow here so you can know that it'll be -6 and 1/4. Right? The 6 from here and the 1 over 4. Right? Okay. So now, actually, so before I depart from this right away, I want to show you something else here that we could have done. This is not really necessary, but I want to show it anyway. Okay. Let me see here. No, it's better that we leave it just like this, okay? And then, but I do want to take a moment here to show you how we could have gotten the vertex using the formula that we used earlier for the standard form of the quadratic. Okay, so we already got the vertex. We could already plot it based on this vertex and stuff. But I also want to show you how, if we wanted to, we could have still done the x-vertex form from the past. Okay? So let's do that here. Right? So for a quadratic in standard form, for example, y equals ax squared plus bx plus c, the vertex is x coordinate, which we labeled the x vertex, is given by x vertex equals -b over 2a. But this is not a standard form, right? But what we can do is we can distribute, right? We can calculate what this will become. X times x is x squared. X times -3 is -3x. Then it'll be plus 2x. And then the plus 2 times the -3 becomes -6. I know that I'm straining here with my thumb and finger to keep track of the multiplications, but if you do it on paper, it's very nice, because you don't have to put like the arrows, the first with the first, the outer, the inner, and then the last with the last. But of course, however you want to do it is your prerogative. But if you do it like this with your fingers to guide you, it'll be very clean. The only thing left here to do is to combine the like terms, which are these two. So I will get x squared minus x minus 6. By the way, I want to again reiterate that what I'm doing right now is not necessary. Okay, I'm just doing this as an extra so that you can see that we can do it with the old vertex formula, which we got over there. Okay. Okay, so this vertex formula, so I now have, what I've done basically, let me just make this point here. I've taken this quadratic, which we were given, which was in factored form, and I've rewritten it as a quadratic in standard form, with a equals 1, with b equals -1, and with c equals -6. Okay? And so now I can get the x vertex. The x vertex is going to be -b over 2a, which will be negative of -1 over 2 times 1. The negative from the formula, the b is -1 because of that, and the a is 1 because it's the coefficient of the x4 term. And that, of course, implies negative of negative is +1, so it's 1 over 2 times 1 is 2. So we can see that we still get the same x vertex, the same x coordinate of the vertex. And then, of course, if we wanted to, we could plug it in here, and we could get the y vertex, but we're not going to do that, because I know that from here you could do it. And I encourage you, if you would like, you can plug it into this form, and you can see that you will get the same vertex. Okay? Okay. So now we have found the vertex, okay? Now, does it open up or down? We saw, when we wrote it in factored form, that this a is 1. It's +1 in this case. And so it must open up, okay? Moreover, it's a quadratic, so that means that the domain is going to be from -infinity to infinity. The only thing that's left to discuss is the range as far as like our preliminary information. We can see that it opens up. So we know that this vertex value, the y value, will be the minimum achieved by the function. And so therefore, we're going to put our square bracket, we're going to put -25 over 4, and then we're going to put infinity, close bracket, because since it's going to open upward, that's going to be the minimum, and the range is going to go from that minimum, including that minimum, to infinity upwards. Okay? And so now we're going to do the graph. Okay. So now I'm going to graph my quadratic, and I need to keep in mind what points I want to like be able to put on our graph. I know I'm going to need to have the x coordinates -2 and -3. I know I'm going to need to have my y coordinate -6. So that means that what I'm going to mostly focus on when I'm graphing this is I need a little bit of the x on the left and a little bit of the x on the right, but a lot of the y on the bottom, so I can get these points. And so, by the way, I want you to notice that, like, how I think about how to make the x and y axis to draw the parts that I need. Okay? And I want you guys to also think the same way. Well, I mean, I don't want you guys to think like me in that sense. I mean, you know, I don't want you guys to be copies. But I want you guys to realize that, like, when you're drawing a graph paper, you can draw it the way you need it to be to match the problem at hand for you guys. Okay. Okay. So here, as you can see, I have the -2 right there. I have the 3 there. I have put my points there because those are the x-intercepts, right? I put my point here for my y-intercept. Now, my vertex is 1/2 and -25 over 4, which we saw simplifies to -6 1/4. So I can go in here and I can see, aha, this is 1/2, and I can go down to -6 1/4. Notice how I split up from -6 to -7. I split it up into 4 pieces so that I could plot the vertex exactly. And then I know that here, by reflecting across the axis of symmetry, I know I'm 1/2 away to the left, it's at -6. So if I'm 1/2 to the right, which is x equals 1, I will also have y value -6. So right there, I want you to notice how I use the axis of symmetry there. I'm surprised we didn't write that here. Let me just fill it in. The axis of symmetry, which we'll call AOS, is going to be the vertical line x equals 1/2, because it's the vertical line x equals a constant, where that constant is the x coordinate of the vertex. So now we've drawn all the points we need to graph this. So let me try and draw it like as nice as possible. Oh my god, I think I actually did a relatively respectable job there of the graph. And so now, earlier I had mentioned that it would have, earlier I had mentioned that it was likely that, or not that it was likely, earlier I had mentioned that I was going to come back to talking about when you have a quadratic in factored form like this, or in general, if you have a quadratic where you know what the x-intercepts are, that you can recover the vertex. Okay? At least the x-coordinate of the vertex. And I'm going to explain why that is here. Now, if you take this distance, okay, and you take this distance, you will see that it will match. Because that's basically the property of the axis of symmetry, right? And so if, let's say we didn't know what the x vertex was, but we did know it crossed those 2 points, -2 and 3. If we take their midpoint, okay, we will find the x coordinate of the vertex, okay? Let me see here. Let me see here. Stand by, please. If you add these two, and you will get 1, you divide that by 2, you get 1/2, and you recover the x coordinate of the vertex. So in general, if you have the graph of a quadratic, and you know the two x-intercepts, in this case, we got them, -2 and 3, and you take their average, you will recover the x coordinate of the vertex. So I wanted to make that little bit of a little observation earlier. You can always use the formula as I put it on the side, which ends up amounting to the same thing. But I wanted you to see why that was. And in general, if this, now I'm going to go off a little bit on a tangent here. Let's suppose instead that I knew that at, let's say, the value y equals -2, let's say I had this horizontal line. And let's say that, let me see, at -2, 0, no, wait, I'm sorry. That's this -2. Okay. So if I had this point here, if I knew what that x value was, and I knew what this x value was, then I could take the midpoint of those and also recover the x vertex. Okay. Well, anyway, I hope that you've enjoyed this discussion, and I hope to see you again in the future with more examples. Thank you.